Good morning, ladies and gentlemen. Today 3 here at the EMO 2025 in Hannover on our innovation stage. Yesterday was a day full packed of innovations, great speeches, and some fantastic discussions here. I remember overall the discussion with Dr. Kalweit from the VDA, and I can tell you today there's another great program waiting for you. We have a lot of innovation here on stage where you can see new technologies, new companies, startups that are presenting their solutions here. And 2 big highlights are waiting for us today as well. The first one is we will discuss with Julia Jäckel what the situation of the German state is in regards to the development for our industry here. And secondly, we will have 3 exciting speakers here on stage and discuss with them what the importance of AI in production nowadays is and what the future look like. So you can wait for a fantastic program. And what could be better with a day on Innovation Stage to start with a fantastic program point. And I'm happy that we're talking about a new technology, forging technology. Neotecman from Spain presents an all-in-one forging solution that integrates efficiency and innovation into a single process. And I'm pleased to welcome Alain Delem, area manager at Neotecman at stage. And very important for you, you can ask questions via Slido that I can ask Alain after his speech. Afterwards, you will find the QR codes everywhere. You can go over there, Alain. And yeah, big applause for Alain Delem. Alain, stage is yours. Enjoy.
Well, thank you very much. It's my pleasure to introduce you to the all-in-one technology developed by Neotecman. It's a forging solution, but all-in-one solution, which is quite different from the traditional forging systems. Apart from the forging system by itself, we will see the new trends in the industry and how we fit into those new trends. The first thing I want to talk briefly about is the company itself. Neotecman was founded about 35 years ago by people who come from the background of the forging. The founders of the company were actually forgers, but they were pretty displeased with their machinery, and so they started modifying these machines, modifying to such a point that they created a completely new machine. And this new machine is the result of years of investigation, but the important thing is that from people of the industry, people of the company. So the founders of Neotecman knew what forging means and knew what the needs of forging industry were, okay? You're going a bit too fast, but that's okay. So now we have 2 production plants it's okay. Go to the next one. We have 2 production plants in Girona, near Barcelona, Catalonia, Spain. Okay, and we have 130 or more references in the world. That means we have 130 machines actually currently working. It may sound a little number, but think that we are oriented to a very niche, a very specific market. We are only dealing with the forging of brass or aluminum parts made from bars with a maximum diameter of 65 millimeters. We do not deal with iron, we do not deal with stainless steel. We only deal with non-ferrous materials, mainly copper, brass, or aluminum. Okay? We work in the field of gas, water distribution, hydraulics, pneumatics, and automotive. And this is because the technology that we use uses punches to create a part through which a fluid will flow. We want to make sure that we will use as little material as possible to help a fluid go through the part. So this is why we have a very niche market, very specialized, and maybe such a little amount of machines worldwide. But still, we consider that 130 machines is quite an important number. So the all-in-one forging concept. What do we mean by all-in-one? This is what we are going to see now through a little video. But before we start the video, by all-in-one, we will have just one machine that will replace all the circuit, the traditional circuit from traditional forging. Traditional forging usually meant taking bars, brass bars, aluminum bars, cutting them into billets, spraying or plunging those billets into a graphite oil, bringing them into a furnace, bringing them from the furnace into the press, forging them, and then clipping them because there is flash all around it. This concept required of anything between 3 and 8 people, required from several areas in the factory, and required quite a lot of energy and time. By our all-in-one concept, we have reduced this to a small area of the factory. The basic machine is 4 by 5 meters, so we're talking about 20 square meters in the factory, which is very limited. And we will go from the long, cold bar straight into a part, flashless, forged, ready to be machines. Okay, in just one operation. We will heat, we will cut, and we will forge flashless. So just one person can handle one machine and replace 8 people and 5 machines. This is what we call all-in-one forging system. Now we will see the little video, and you will see that with one machine, we will go from the long bar to the part forged, flashless, and ready to be machined. So in one side of our machine, we will bring 1 ton or 2 tons of long bars, and those bars will be taken one by one and brought into the furnace. Once they are allowed into the furnace, they will start, obviously, heating. But we will heat the whole bar. We will not heat billets. And we heat several bars at a time. So we save a lot of energy. The same energy used for heating a few billets is now here used for forging, for heating many bars. So there is an important savings on energy at this stage. Once a bar is hot, we will push it, as you have seen, we will push it from behind, and on the other side, we will receive it, and we will determine its exact length. Once we have determined the length, we will shear it, and when we shear it, we do not cut it with chips. There is no chip, there is no waste, there is no material to be recycled. It's a clean cut, always the same cut, at the length that we have decided. The length means the exact weight, quantity of material that we will need. This is what enables us to forge flashless. We can adapt that length at any time with the machine itself. We can adjust the length. Now, once we have our hot billets, we will bring them onto the die, and inside of the die, once it is closed, our punches will start spreading the material around. This is why we do not have flash. We are not smashing the billet. We are spreading the material inside of the die to make sure that it goes everywhere we need it and give the perfect shape to our part. And once it is forged, we will retrieve it from the die, and we will collect it. And you can see that we forge flashless. If you see the parts, there is no flash. That's how the parts comes from the machine. They do not need to be clipped. So once again, we save material because we do not have any flash to recycle. We don't have any flash, we don't have any chips, so we save quite a lot of raw material. this is it for the video. If we can come back to the presentation, thank you very much. So the fact of saving the chips and the flash, of course, this is not a waste. This is recycled. But even this recycling has a high cost. It has an important cost which you do not have to operate with our system. Typically, the forgers will stop buying between 15 and 25% of raw material, because it is raw material they do not need, because afterwards they would recycle it. Here, as we don't have this recycling, you do not need to buy that much raw material, okay? So we're talking about real savings. Apart from the space, apart from the people, from the staff, apart from the energy, we are talking about real savings. Okay, not only do we have one compact machine, but inside the machine we use new technologies like IO-Link. For the last 3 to 4 years now, we've been developing our machines using IO-Links every time more and more. This allows us to, well, the IO-Link system is essential in the communication. Okay, this enables us to detect the problems of the machine much faster. It allows us to have remote diagnostics. Okay, we have much more information on what's going on inside the machine through this IO-Link. Okay, we can understand much better what is happening, we can understand much better what is failing, and we can see much faster how to react to that. It is plug and play. It is a lot easier to install than typical wiring from all the elements towards the PLC or towards the computer. We get more data, we get a better understanding of everything. And it is made of simple and reliable components. So altogether, it's a big win, both for us, the manufacturers, and also for the customers, and also for the service team, who is supposed to check and fix all the problems that we may have. Okay? All this machine is built in a way that there is no need to change anything if we want to use eco-friendly material. We can, without any problem, work with lead-free brass, lead-free material. It's just a matter of adapting the speed or adapting the times, but all the equipment by itself can be used also for lead-free brass or whatever material. We need to adapt the temperature and we need to adapt the cycle times. Okay. We have two sources of energy. We can heat the bars, as you have seen in the video, with gas, or we can heat them with electric induction. If we use gas, we try to save as much gas as possible. As I explained, we heat up a lot of bars at the same time, so we share the same energy for a lot of billets, for a lot of parts. And not only when we heat, but when we forge, we have developed a machine that allows us to forge up to 4 parts at a time. So that means that all the energy which is used into the machine will be shared between many bars on one side and 4 parts on the other side. Indeed, it does not take 4 times more energy to heat up and to forge 4 parts than 1, but it just requires a little bit less, a little bit more. So we save a lot of energy when we can forge 4 bars. You see the difference between 1 piece or 4 pieces per cycle is only just a little bit of energy necessary. See, the fact that we have the same power used for the ram and for the punches helps us a lot to save and to control the energy. Thank you. As I said, we have gas heating system or electric induction heating system. Obviously, electric induction is a CO2-free heating system, so it is green, and this leads us much more towards Industry 5.0. Okay, we have a very good control of energy with the use of 4 pyrometers at 4 different points inside the machine. We can control the temperature and make sure that we are controlling this temperature. With our induction system, heating system, we can guarantee a ±5 degree stability in the temperature. So this, once again, is a great help in controlling and saving the energy. Okay, we will also, with this technology, we do not need to prepare the machine before. We do not need to heat the machine 20 or 30 minutes before. It is instant heat. So you just press on the button, and after a few seconds, maybe 1 minute, you got the first part absolutely finished. Okay, so it is once again all oriented towards Industry 5.0, saving energy, working greener, and this is how we contribute to that. So altogether, the benefits for the customer are the fact that as it is all in one, well, there's only one machine to handle. There is very few people, because I told you one person can handle up to 2 machines, so it is a lot simpler. The infrastructure is a lot simpler, reduced space, reduced personnel. We have a much better control. We have advanced monitoring. We have our I/O interface, which is very powerful, gives us a lot of information, which will help us for the diagnosis and for the repairing, for the solving of solutions. We save a lot of material, no chip, no flash. Just that will help pay the machine in 2 to 3 years just by the materials savings. It's a full automatic installation, so this is also very important. It's a machine which is easy to install. We do not need any heavy work to install the machine. The machine is just laid on the floor. It's a very easy process. And as I said, we have up to 4 pieces per cycle. So we have a high energy. We have machines that can produce 4,000, 4,300, 4,600 pieces per hour. Energy efficiency, green options, and this is really our way of seeing the future of forging. And our motto is the best way to create the future is to invent it. Okay, I thank you. I want, yes, we have machines all around the world, except in Australia. We still don't have machines in Australia, but we have machines in Africa, in America, north and south. We have machines in Asia. And here we have a Chinese company with a few machines of ours. And we are getting there more and more, but we are happy to share this with 130 customers. We thank you very much. If you have questions, I'm sure that we will find a solution. We will find an answer.
First of all, thank you so much, Alain. Fantastic presentation.
Thank you.
I think this is absolutely worth an applause. Thank you so much.
Thank you very much.
I must admit, Alain, that of course I'm not an expert in forging, so I prepared some questions, but feel free if you have technical-based questions, because I wouldn't be able. But there are a few things that came to my mind. So you mentioned the higher efficiency, less energy, so a better CO2 footprint. What would be interesting for me, especially if you're here at the EMO and talking to potential clients, how important is that nowadays for clients? Because it's mentioned so many times, but is it really important for the client?
It is really important. I mean, the price of energy worldwide has increased a lot. In some countries, electricity will be much more expensive than gas. In some country, gas will not be available, and energy is at a certain rate. But energy is still the number one problem of the manufacturers. I mean, the cost of the energy is the real cost of the production. So if you can save that energy and produce 4 pieces instead of 1 with the same energy, you increase a lot your capacity and you decrease
your ROI, basically. ROI, yeah, perfectly. So, I mean, it's a European company where you changed a little bit forging. You put several technologies in one machine. That's what I got, basically, isn't it?
In fact, some people consider that we are not really forging, because forging, the original forging was really smashing apart or hitting it with a hammer. We don't do that. We don't do that. We mold it. We push the material to where it has to go. We don't deform it. We push it. We place it. It is.
So, yeah, but then would be the question. So, is that appreciated by the customers in terms of compared to the hammering forging? Let's put it that way.
It is very much appreciated because technically it has been proven that the quality of the forged part, forged this way, is at least as good, if not better, than the traditionally spanked parts. And also the aspect is much better, and the finishing of it is much better.
Okay.
So it is greatly appreciated, yes.
Then another important question, at least from my side, where, I mean, we're talking lack of staff is one of the main topics we're talking about all the time. So you mentioned you need less operators. One operator can operate the whole machine. When you think about the phase of developing the machine, was that one of the key central points that you had in mind when developing the machine? Because it is a common problem. It would be.
It is. I don't know if it is really a key that we keep in mind when we develop the machine, but it is a key point for the people, for the companies. I mean, I have customers who told me, no, we don't want to get into forging because people in this country don't want to work in such conditions. And I say, hey, conditions have changed quite a lot. It's not noisy. You don't have the typical boom, boom that you hear.
I know that very well. So.
When you go to a forging company, it's quite the amount of noise which is issued by the machine is less than 84 decibels. So it is not noisy, and it is not dirty. The whole thing happens inside of one machine, and it is not dirty. So it is very appreciated by the companies because nowadays personnel does not want to work in dirty conditions.
Okay.
So
when we're talking about this is a closed machine, you mentioned the noise. It reminds me a little bit of additive manufacturing if it comes to build space, so the build chamber, if you want it. Is there any limitation in size of the parts?
Yes, by the machines have been built to accommodate bars with a diameter up to 65 millimeters. So, as I explained, most of the parts we do will be used in the piping industry, piping for water, piping for gas. So the typical biggest part that we can make is a 2.3 inches part. That is the maximum size we can reach.
Okay.
From a 65 millimeter bar. Okay, but that's not in this sector, in this part of the industry. The most typical parts will be done with a range of 0.5 inch to 1.5 inch.
Perfect.
So
perfect.
2 inches is already a big valve. 2.5 is a very big valve. Or then you have to go to another sort of industry.
So, and the last question that you probably allow as a non-technician, does the speed changes? You implemented new technologies or new forms of doing it, as far as understood. So does the speed of producing, the amount of parts you can do in the same time being reduced, is higher or same? What would you say? Because beside energy, time and volume is a critical.
Our machines are considered high production machines. So as I told you, according to the part, of course, you will not produce the same amount of part if it's a round ball or if it's a complicated part. But we can produce up to 4,600 parts per hour. So it's a high production.
Absolutely.
High production machine.
Great. Let me have a look. No questions there. Alain, thank you so much. I enjoyed a lot, and that.
Thank you very much.
Thank you so much. Great.
Thank
Alain Delem, big applause. Neotecman, thank you so much for presenting your innovation.